Hello everyone, thanks for joining in. Today we are going to discuss these four topics. First one, multi-protocol configuration. So in our topology today we are going to use three protocols: EIGRP, OSPF and ISIS, and also we'll do the configuration as well. And the next topic will be route distribution. So we'll do the redistribution between these three protocols, and the third topic will be route leaking, and the last one BFD for ISIS. So let's start with the topology first. So for today, this will be our topology. Here, each router has one loopback, like R1 has 1.1.1.1, R2 has 2.2.2.2. Similarly, R3 has 3.3.3.3, R4 has 4.4.4.4. Similarly, for R5, R6, R7, R8, R9, R10, R11, and R12. So here R1, R2, R3 and R4 is in area 49.0001, and R6, R7, R9, R10, R11 and R12 in ISIS area 49.0000, and router R5 in EIGRP autonomous system 111, and router R8 will be in OSPF area 0. Sorry. So let's start with the configuration. So I have already configured the IP address. So here we can see that between R1 and R3, we are using 13.1.1.0 subnet. Between R1 and R2, we are using 12.1.1.0/24. Similarly, between R2 and R4, we are using 24 subnet. Between R5 and R6, we are using 56. R6 and R9, we are using 69. Between R9 and R11, we are using 91, and between R11 and R12 we are using 112, and between R10 and R12 we are using 102, between R7 and R10 we are using 70, and between R7 and R8 we are using 78, and between R4 and R7 we are using 47 subnet, right? So let me show you. We'll do the configuration on each router one by one. So let's start with EIGRP, that is R5. So we will go in R5. Here let me show you that IP address is already configured. Sorry. So here G1 by 0 IP address is configured 56.1.1.5, and we have created one loopback, that is 5.5.5.5. Okay. So let's enable the EIGRP, that is 111 autonomous system, and we'll have to advertise the subnet 56.1.1.0, and wildcard mask will be 0.0.0.255, and we'll have to advertise here the loopback, that is 5.5.5.5, and the wildcard mask will be 0.0.0.0, right? Now we will move on R6. So in R6 we have to loopback 6.6.6.6 and 60.60.60.60. So we are going to use loopback 10 for EIGRP and loopback 0 for ISIS. Okay, so let's enable EIGRP here, router EIGRP 111, and the network is 56.1.1.0, and wildcard mask will be 255, and our network is, as I said, that we are going to use loopback 10 for EIGRP. So our loopback 10 is 60.60.60.60, and subnet mask will be 0.0.0.255. Sorry, 0, because we are going to use /32 for loopback. Okay, so let's see that our EIGRP neighborship is established or not. So it's done. So I should receive the route 555 at R6 and vice versa, right? So let's enable the OSPF on R7 and R8. So here I'll show you that we have already configured the IP address. So here we can see that on interface G4Y0 we have configured 78.1.1.7, and we have two loopbacks here as well, loopback 0 7.7.7.7 that we will use on ISIS, and loopback 10 70.70.70.70 for OSPF. Okay, And here G2 by 0 we are using 70.1.1.7. On interface G1 by 0 we are going to use 47.1.1.7. So let's configure the OSPF. So router OSPF 1, I am just assuming the process ID 1, and here we'll have to advertise the interface, that is 78.1.1.0, and the mask will be 0.0.0.255 and area will be 0, and we'll have to make a router ID is 70.70.70.70, and we'll have to advertise this subnet as well, network 70.70.70.70, and while mask will be 0.0.0.0 and area will be 0. Here we are taking wildcard mask 0.0.0.0 because we are using /32 for loopback. And here after that we'll move on R8. Here we can see that here we have only one loopback, that is 8.8.8.8, and on interface G4 by 0 we are using the IP address 78.1.1.8. So we will go in router OSPF1, and our network is 78.1.1.0, wildcard mask is 0.0.0.255, area is 0, and router ID is 8.8.8.8, and we'll have to advertise this subnet as well. So 8.8.8, and our wildcard mask will be 0.0.0.0, area will be 0. So here we can see that our OSPF neighborship is established, and I should receive the route 70.70.70.70 in R8 and vice versa, right? So let's enable the ISIS in each router. So let me copy in one notepad so it will be easy for us. So let me minimize it, and first we will do the ISIS configuration for area 49.0001. Okay, so command will be router ISIS. Here our net ID will be 49.0001, and our system ID will be 000000000001, and our intermediate system will be 00, right? And here, as we discussed in the previous lectures, that we will make the internal router as a L1, right? So I will make router 1 as level 1. Okay, now we'll have to call the interface inside ISIS. So interface G1 by 0, IP router ISIS, and interface Z2 by 0, IP router ISIS, and a loopback, that is interface loopback 0, IP router ISIS. So this is the command for ISIS. So we'll do the configuration on R1. So we will go here. So before that, let me show you the IP address what we have configured. So here we can see that on interface G1 by 0, we have configured 13.1.1.1. On interface Z2 by 0, we have configured 12.1.1.1, and we have one loopback, right? So let's configure that. Sorry. So it's configured. Now we will go on R2. So let me show you the IP address. So here we can see that on interface G2 by 0, we have configured 12.1.1.2 because it is between R1 and R2. And between R2 and R4, we are using subnet 24.1.1.2, and we have one loopback. So let's modify this configuration for R2. So our area is same 49.0001. Our system ID will be changed from 1 to 2. And this router will be as level 1, and interface is G2 by 0, and here G3 by 0 and loop back 0. So let's implement on router 2. Here we can add one more line, config T, right? So let's move on router 2 and apply this configuration. So we can see that ISIS neighborship should be established. So here L1 neighborship is formed. Now let's move on R3. So here we can see that IP address that we have configured. So on interface G1 by 0 we have configured 13.1.1.3, and G4 by 0 we have configured 36.1.1.3 between R3 and R6, and we have one loopback 3.3.3.3. So let's modify for R3. So here our area is same 49.0001, and system ID will be changed here. So our system ID will be 3. Our edge router will act as level 1 2, so will not do here anything, and interface is G1 by 0 and G4 by 0 and loopback 0. So let's configure R3, and in router 4 here between R2 and R4 we are using subnet 24.1.1.4. Between R4 and R7 we are using subnet 47.1.1.4, and we have one loopback 4.4.4.4. So let's modify. So our system ID will be changed here, and our interface is G3 by 0 and G1 by 0. So G3 by 0, right? And loopback 0. Sorry. So let's apply this configuration in R4. So we can see here that it should establish the neighborship with R2, right? That is L1 neighborship. Now let's move on our another ISS area, that is 49.0000, and in this area we can see 1 2 3 4 5 6 routers are there. So here are 6. So let me show you the IP address. So we already showed you, but let's see once again. We have two loopbacks, loopback 0, loopback 10. So loopback 0 we are using here for ISIS, and the interface, so G4 by 0 is configured as 36.1.1.6, and G2 by 0 is configured as 69.1.1.6, right? And this interface we are using for OSPF. So let's configure, but here we can modify for R6. So our area is 49.0000, and our system ID will be changed to to 6, and interface is G4 by 0 and G2 by 0. Yeah, and we have one loopback 0. So let's apply this configuration on R6. Now move on R7. So here we already discussed the IP interface, but let's see once again, we have two loopbacks here. So we are using loopback 0 for ISIS, right? And for 1 by 0 we are using 47.1.1.7, and for 2 by 0 we are using 70.1.1.7, and G4 by 0 we used for OSPF, right? Sorry, in R6 so we used G1 by 0 for EIGRP. I think I said for OSPF earlier, right? So was my mistake. So R7, so let's modify this configuration. Our area will be same 49.0000, and our system ID will be changed here from 6 to 7, and R7 has interface G1 by 0, that will be in ISIS, G2 by 0, and yes, only two interfaces and loopback 0. So let's apply this configuration, right? Now let's move on R9. Let me shift right. Okay. Now here we can see the IP address we have configured on R9. So R9 on interface G2 by 0 we have used 69.1.1.9, and on interface G3 by 0 we are using subnet 91.1.1.9 because it is in between R9 and R11, and we have one loop back, that is 9.9.9.9. So let's configure this. So area 49.0000, our system ID will be 9, and we have two interfaces 2 by 0 and 3 by 0. So 2 by 0 and 3 by 0, and we have one loop back. So let's apply this. Now we will move on R10. So here in R10 we don't need loopback 100, so let's delete that. No interface loopback 100. Now so IP interface brief. Now so here on interface G2 by 0 we are using subnet 70.1.1.0 because it is in between 7 and 10, and on interface G3 by 0 we are using subnet 102.1.1.10 because it is in between 10 and 12, right? And we have one loop back 10.10.10.10. So let's modify our configuration. So our area will be same 49.0000, and here our system ID will be changed from 9 to 10. So here, as we know that A we use for 10 in hexadecimal, right? And we have two interface, that is G2 by 0 and G3 by 0, and one loop back. So let's apply this configuration in R10. So we can see here that neighborship should be established with R7. So here let's assume that this is our transit area, right? So in previous lecture we already discussed that in transit area all router we configured as L2 router, right? So we'll have to change each router as L2. So let me modify this. No problem, we'll do later after the configuration of R11 and R12. Okay, so now we will move on R11. Here we can see that IP address that we have configured is yeah. So in R11 G1 by 0 we are using the subnet 112.1.1.11 because it is in between 11 and 12, and on interface G3 by 0 we are using subnet 91.1.1.11, right? And we have one loop back, that is 11.11.11.11. So let's modify this configuration, and our area will be 49.0000, and system ID will be changed from A to B, and the interface is G3 by 0 and G1 by 0, G3 by 0 and G1 by 0, and one loop back. So let's apply this configuration on R11. Now we will move on R12. And here we can see that we have two interfaces. G1 by 0 we are using IP address 112.1.1.12, and for interface G3 by 0 we are using IP address 102.1.1.12, and we have one loop back 0, that is 12.12.12.12, right? So let's modify the configuration as per our requirement. So here area is same, and our system ID will be changed from B to C, and the interface is G3 by 0 and G1 by 0 and loopback 0. So let's apply this configuration, and we should see the neighborship. So ISIS neighbor, so it has established with R11 and R10. So before that we'll have to change all these routers as level 2, right? Because this area we are considering as transit area. So here we'll have to go here and IS type level 2. Okay, let's apply on each router, that is R6 to R12, R6, R7, R9, R10, R11. Actually, we are making L2 because we want to reduce the memory consumption, right? Also, it will make the two neighbors with each router L1 and L2. Now, if we will see that it will establish only L2 neighborship with each router. It will take some time to come up. So let's wait. So as neighbor. So here we can see that now it's establishing only L2 neighborship in R7 as well. R7 with R10 L2 neighborship and with R4 only L2 neighborship. Right? Earlier it was making L1, L2 both. So our configuration is done. So let's do the redistribution part. So we'll have to perform the redistribution on R6 and R7 because on R6 we are using protocol EIGRP and ISIS both, and on R7 we are using protocol ISIS and OSPF. So let's redistribute first on R6. So here we will go in EIGRP, that is our autonomous system is 1111, sorry 111, and here command is redistribute ISIS. So for ISIS, we are not using any process ID. So here, as we know that in EIGRP, we have five metrics, right? So if we will do here question mark, so it will ask me to put the metric. So here, first it's asking me bandwidth. So I'm just assuming that bandwidth is 10. Then after that, when we'll do the question mark, so it will ask me to please put the delay. So I'm just assuming the delay is 10, and when we will do the question mark, so it's asking me please put the reliability, so I will put here 10, and when we will do the question mark, so again it's asking me please put the loading, so I'm just assuming loading is 10, and when we will do the question mark last, so it's asking me to put MTU. So there are five metrics we use in EIGRP, that's why we are putting all five metrics. When we will do hit enter here, so all the ISIS routes will be moved in EIGRP, right? Now let's redistribute EIGRP routes in ISIS. So router ISIS, and here command will be redistribute EIGRP, or autonomous system is 111. And as we know that in ISIS each interface has a cost only 10, right? So default metric is 10. So we don't need to put anything, just hit enter here, and redistribution part is completed. So when we will see in R1, I should receive the R5 routes, not R1, because this area will become as totally stubby. So this route only receive the default route, right? So, but I'll be able to ping 5.5.5.5 source 1.1.1. See, it's pingable. Now let's redistribute OSPF in ISIS and vice versa. So we'll move on to router R7 here. So let's first redistribute ISIS in OSPF. So router OSPF, our process ID was 1, and command is redistribute ISIS, and here question mark. So here it's asking me please put the metric. So default metric is only we use for bandwidth, right, in OSPF. So we don't need to put, just to use keyword subnets for class full, right? So our redistribution part is completed. So let's move in ISIS, and the command is redistribute OSPF 1. That's it. So I'll be able to ping R8 as well. See, it's pingable. Now in R3 we can see that all the routes, so IP route, SIS, sorry, so IP route, ISIS. So here we can see that in R3 we have 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All the routes we have, and we have full reachability in our network. Now let's discuss here our third topic, that is route leaking. So when we have to exit in our area, so as we know that this is our totally stubby area, and we have made this router as a level 1 router, right? And here we can see that we have only default route, no other routes of ISIS of another area, right? We have only default route, not 5, not 6, not 7, not 6, not 9, not 10, not 11, not 12. Only we have internal routes, that is so 2, 3, 4, and the subnets between the routers, right? So, but we have all the reachability. So here route leaking concept comes when in our area we have two exit path. Okay. Now let's suppose that R10 here has one loop back, right? So when R1 will try to reach 10.10.10, then automatically, as we know that in this routing table 10 prefix is not there, right? So when I will apply the ping 10.10.10.10 source 1.1.1.1, so first it will check its routing table. So do we have this prefix in its routing table? It will not find, so it will check the next path. What will be the next path for this? So it will check our next path is 13.1.1.3, that is this one. But when I will calculate the metric for 10.10.10, so as we know that the default metric in ISIS is 10, right? So 10 here, and 10 here, 10 here, 10 here, 10 here, 10 here as well, and 10 for loop back. Let me put here what happened. Yeah, 10 here. So if I will calculate 10, 20, 30, 40, 50, 60, and 70. So when R1 will take the path via R3, so it has to go to this path, and the path is longest, right? If I will check the backup path, so here the metric is 10, and the metric here also 10, and here as well 10, and 10 here as well, and 10 for loop back. So when I will calculate 10, 20, 30, 40, 50. So in the reverse path, as we know that we have only cost is 50, right? So here this leads to suboptimal routing. So let me write here, that is suboptimal routing. So to avoid that, we have two options. First one is we can make this router as L2, so that all the prefixes will be stored in its routing table, so that it can decide that to reach to R10 or 10.10.10.10, we should choose via R3 path or via R2 path. So when it will see that via R2 it's getting only 50 cost, so it will choose this one in place of R3 path, right? But there is a problem that all the prefixes will be stored in R1, and suppose our internal router has very less capability or very less memory, then our router will be crashed out, right? So to avoid that, we can here use the route leaking concept. So how can we use that? So on our edge router, we'll have to use redistribution, or we'll have to leak these two routes. For R2 we will use 9999, and for R1 we will leak 10.10.10.10. So how to do that? So let's see. In R3 and R4 we will go here. We'll have to go in ISIS, but before that let me show you the output. So here in R1 we don't have the subnet 10.10.10.10, right? And 9999 also, right? So here in R3 and R4 we'll have to create one access list. So let's assume that we are using extended access list, that is 101, permit IP, and our source IP address will be 10.10.10.10, and wildcard mask will be 0.0.0.0, and destination will be any. And we'll use the another access list for 9.9.9.9, permit IP 9.9.9.9, and our wildcard mask will be 0.0.0.0, and destination will be any. Right now we will go in ISIS. The command is for route leaking, redistribute ISIS. Here protocol is IP. So here we can see that this is our level 2 routes, right? So we are leaking level 2 routes into level 1. So here level 2, then we'll do the question mark. So here we can see that we are redistributing, or we are leaking level 2 routes into level 1. So here we'll have to use keyword into, and then level 1. So here when do the question mark, so here I'm getting the distribute list option, that is our access list that we have created earlier. So distribute list is 101, right? Now let's apply on R4 as well. Let's create first access list 101, permit IP, source will be 10.10.10.10, and wildcard mask will be 0.0.0.0.0, and destination will be any. Access list 101, permit IP 9.9.9.9, 0.0.0.0, and destination will be any. Right now, router ISIS and redistribute ISIS IP. Here level 2, we are leaking level 2 routes into level 1, distribute list 101, right? So let's see the output once again. So via 12.1.1.2, right? So we can see in routing table as well. So here we can see that 10 prefix via R2 only, and 9.9.9 via R3, right? So we can avoid suboptimal routing via route leaking, right? So this was the concept of route leaking. So now let's move on our last topic, that is BFD, that is bi-directional forwarding. So actually bidirectional forwarding allows us the capability to detect the neighbor failure, right? Suppose, let me open, actually this is our 7200 series router. So BFD protocol is our hardware protocol, so it will not support on 7200. So we'll have to use here another diagram, and we will use here router, that is CSR, that is our software based router, right? So we'll have to close this topology, and we'll open our BFD topology. So as I said that BFD is a hardware protocol. Okay, so it will not support on 7200 router. That's why we used the CSR 1000 router. Okay. So let's start this router and let's understand the concept of BFD. Actually, as I said, that BFD allows us the capability to establish the neighbor with the router, and it's also used to detect the neighbor failure. So the default timer of BFD is in milliseconds, and as we know that the default timer of ISIS is hello timer is 10 seconds and the dead timer is 30 seconds of ISIS. So when we will enable the BFD in ISIS, then our timer will be reduced and we can identify the neighbor failure in a few milliseconds. As we know that in 1 second there is 1000 milliseconds, right? So in 1 second we can identify that our neighbor is down and we can just switch back to the backup path, right? So let me show you, and here we will apply BFD on G2 interface, and we will first I'll show you that how much time ISS takes to find that our neighbor is down, right? So let's not enable the ISIS on interface G1. Okay, so let me close. Okay, and let's take the console of R1 and R2 and R3. Actually, we have already configured the IP address to avoid the time wastage. So it will take some time to come up because this is CSR 1000 routers. So yeah, all the routers came up. So let's see. Actually, we have already configured the IP address. So let's check. So here we are using 13.1.1.1 between R1 and R3. And between R1 and R2, we are using subnet 12.1.1.0/24, right? And let me see that IP address is configured or not. So it's not configured. Let me quickly configure. So first change the host name and interface G2 IP address is 12.1.1.2 255.255.255.0, no shutdown, and interface G3 IP address 23.1.1.2 255.255.255.0, no shutdown, show IP interface brief, right? So it will take a few seconds to come up. Now find right memory. And now let's move on R3. IP address should be there. So yeah, it's there, right? So let's enable the ISIS on each router. So let's assume that this is our area 49.0000, that is our ISIS. Okay, so let's make the template to enable the ISIS, and here net ID is ISIS, so sorry, 49.0000, and our system ID is 0000 and our intermediate system 00, right? Now we will call inside the interface Z1 and IP router ISIS, right? This is for G1 and similarly for G2. Let's apply this config T. Now in R1 it's applied. Now let's move on R2. Here system ID will be changed. Our area ID is same, and for R2 G2 G3 G2 G3, and here in R3 G1 G3 R3 G1 G3, and our system ID will be changed from 2 to 23, right? So let's configure on R3. So we will be able to receive all the routes on R3. If I will check that I should receive. So IP route ISIS. So I have received that 12 subnet. So I'll be able to ping 12.1.1. It's pingable, right? So I will show you here when I will do shut this interface, then ISIS will take few seconds to detect that our neighbor is down, right? So let's move on R1 and make this interface down. So interface G1, okay, and shut. So let's move on R3. Let's see how many seconds it takes to detect that its neighbor is down, right? So as I said that the dead timer for ISIS is 30 seconds. So it will take approx 30 seconds to detect, right? So let's wait and see. Here R1 we got the message immediately, but still here we can see that now it finds that its neighbor is down. But when I will enable the BFD on this interface, it will detect immediately in milliseconds. So here we have to, so actually BFD configuration is done in two steps. First, we will enable the BFD inside the interface, and second, we have to link the BFD protocol with the running protocol so that that running protocol can link with all its neighbor, right, to detect the neighbor failure. So let's configure on interface G2. I'll show you how to configure that. So let's go in interface G2 and command is BFD interval. As I said that BFD interval transmission is 300 milliseconds and receiver is 300 milliseconds. So it will send the hello message in each 300 milliseconds. Now I will use here keyword multiplier and 3. So it will send 3 hello messages per 300 milliseconds, and when it's received the reply from its neighbor in 3 hello messages, then it's okay. Neighbor is fine. But if it doesn't receive the reply from its neighbor, then it will consider that his neighbor is dead, and it will immediately inform to running protocol, and will also declare that its neighbor is dead now. Okay, so we have apply the BFD inside interface, and we will go inside the protocol. That is, our protocol is router ISIS, and here we'll have to apply the BFD on all interfaces. Okay, we have to do the same thing on R2 interface G2, and the command is BFD interval 300 milliseconds, that is for transmission, and for receiver we are using the same 300 milliseconds, and multiplier is 3. Now we will go in ISIS, that is our protocol, and we'll have to apply on all interfaces, right, so that it can work on all the neighbors, right? So our BFD is applied, so we can see here that our BFD neighbor is established with R1, right? Our state is up. Now when we will do shut this interface G2, immediately we will get the notification that our neighbor is dead. So let's shut this interface G2 and shut. So here we can see that immediately we got the notification. So BFD is too fast, and we apply in all the routing protocols, or we can say in HSRP we can apply too fast our convergence. Okay, so that was the agenda for today, folks. I hope you have learned something new. So till the next video, I'm signing off. Take care.